Hello and welcome back to Geometry, Chapter 5, Section 5. Proving triangle congruence by side, side, side. Alright, side, side, side congruence theorem says that if all three sides of one triangle are congruent to all three sides of the second triangle, then the triangles are congruent. So if you had three sides, three different lengths, here we go. If we had these three lengths here, there's only one way to put them together to make a triangle. Okay, so I place that on there, and then if I know it's this length, there's only one way to connect the ends there, and that's with this length right here. Alright, so let's see, there we go, just like so. Only one way to connect those three sides to make that triangle. So if I know all three sides are congruent, I can only make one particular triangle out of those. Alright, I am to prove that these triangles are congruent. I am given that KL is congruent to NL. So I know this side is congruent to this side. I'm going to make a note up here that that's a side. This is given. Okay, then I know that KM is congruent to NM. That's this side and this one right here. That's also a side. Alright, that's also given. And then step 2, given. Now, I know that LM is congruent to LM because reflexive property. Right? And that is also a side. So, I know triangle KLM is congruent to triangle NLM because, this is step 4, side, 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 side. There we go. Alright. Have a look at these two benches. Which one do you think is going to hold up a little bit better than the other one? Which one's going to be more stable? And why is that one going to be more stable? Okay, if you look at these, you'll probably figure out that it's this one that's more stable. Okay, it's explain why the bench with diagonal support is stable while the other one without support can collapse. Well, here we have a triangle, okay, and that's a fixed lengths. So, because bench 1 is made up of triangles with fixed lengths, with fixed lengths. Comma. Side, side, side congruence theorem tells us that it cannot move. There's only one way to arrange those sides in a triangle. Something to that effect, right? Side, side, side says this angle can't change. There's only one way to arrange these. So, there we go. That's why bench 1 is the more stable. Okay, so we've learned a couple methods of proving triangles congruent. We've learned side, angle, side. Important that it's the included angle. That's why this is in the middle between the two. Side, angle, side. We just learned side, side, side. Those are congruent. What about side, side, angle? Okay, if we know two sides and an angle, can we make an identical triangle? Okay, so I take this side and the angle, And I know that this is this length, so would I have to make the exact same triangle? Well, if I line it up this way, I'd get the same triangle there. However, I could also take that same length and line it up this way and have a triangle. That's not congruent, right? So just having one angle and the two sides, if the angle is not the included angle, then that's not enough, because there's a different way that I could line up that side to make another triangle. All right, so side-side angle is not enough. However, if we have a hypotenuse and a leg, so we have a right angle here. Hypotenuse is always across from the right angle. Remember, that's C. C is the longest side. And we know one of the legs. Then, if the hypotenuse of a right triangle and a leg are congruent to the hypotenuse and the leg of another right triangle, then those two are congruent, because there's only one way to line that up. Okay, using the hypotenuse-leg congruence theorem. Write a proof. We know that WY is congruent to XZ, WZ is perpendicular to ZY, XY is perpendicular to ZY, and we want to prove that these two triangles, this triangle, WYZ and XZY, are congruent. Now, one thing that helps to do is split those apart, maybe make yourself another drawing. So move that out and move this out so you can see what are we talking about here. Okay, so we know that these are perpendicular, so I can put a little right angle in there. What else do we know? We know that WY, this line, is congruent to XZ. We know that that's what we know. Okay, we got a right angle, and we know that these two are congruent. Okay, so let's prove this. All right, what are we given? WY is congruent. We're also given these are perpendicular. Because they are perpendicular, we can say those angles, the angle at Z and the angle at Y, are right angles. Hence, these are right triangles. Okay, because definition of right triangle says you have to have one right angle. And the reflexive property tells me that the line at the bottom, ZY, is congruent to YZ. So, therefore, I have a hypotenuse, a leg, and right angle, hence congruent. Boom. All right. Hypotenuse-leg congruence theorem for this example here. The television antenna is perpendicular to the plane containing points B, C, D, and E. Each of the cables running from the top of the antenna to B, C, and D has the same length. Prove that triangle AEB, AEC, and AED are congruent. We're going to go ahead and prove two of those congruent, and then the third one would work the same way. So we're going to start with AEB and AEC. How about that? AEB, that's this triangle back here, and AEC, that's the triangle on the front here. Okay. What do we know? We know that these are perpendicular. That's what we're given right here. So from AE being perpendicular to EB and AE being perpendicular to EC, which we're given, we can say that the angles, angle E, or angle AEC, and angle AEB are right angles. Right angles, because definition of perpendicular. Perpendicular. Therefore, we can say that triangle AEC and triangle AEB are right triangles. Definition of right triangles. And then we know that AB is congruent to AC. AB is congruent to AC. AC, given. We know that AE is congruent to AE. Reflexive property, and therefore triangle AEC is congruent to triangle AEB. Oh, why did I put a line over there? Silly me. There we go. Triangle AEC, because Hypotenuse-Leg theorem. And it would work the same way to do the other triangle. Then I have proved this part. I can prove one more AEC to AED, and then transitive property tells me that one to the next to the next. There you go, ladies and gentlemen. Chapter 5.5, proving triangle congruence by side, along with the hypotenuse-leg congruence theorem. Lots of fun today. Check back in again next time for some more fun in geometry.